All right, with the second day of 2.2, what we're going to look at is continuing some graphing. So last week you looked at this kind of graphing with if it's in standard form. We'll walk through that again quick. And then we'll also talk about what if it was multiplied out and in that ax squared plus bx plus c form. And how you can find the same piece of information there. And then we'll look at a couple of word problems that you'll see in the homework. So our book calls this form that's pictured here, standard form. A lot of books or places will call it vertex form. But in terms of graphing here, one of the first things we do is look at A. If this A value is positive, or if the sign in front of the parentheses is positive, the graph opens up. If it's negative, it opens down. The vertex comes right from this form. The x-coordinate comes from what's being subtracted inside. The y-coordinate comes from outside. And then just remember, the sign of the x-coordinate is the opposite of what it looks like inside the parentheses. The y-coordinate matches exactly what you see after here. To find the intercepts, you just set the whole thing equal to 0, and then solve. And we can solve with square roots. We don't need quadratic formula or anything. The y-intercept you get just by plugging in 0 and crunching out the answer. And then once you have all those pieces of information, once you have the vertex, once you have the x-intercepts, once you have the y-intercept, then you just plot all those points and sketch the graph in. If you have your graph, on the other hand, in this form, ax squared plus bx plus c, we got do a little more digging for some of these things. First, the x-coordinate of the vertex is negative b over 2a. And we have to crunch that out. Then once you have the x-coordinate, to get the y-coordinate, you just plug in that number. So if negative b over 2a is like 2.5, then you would just plug in 2.5 for x into your equation. That would give you the y-coordinate. Then you have the full vertex. To get the y-intercept, we do the same as we did in the other kind. You plug in 0 for x and just crunch out the answer. And if you look at this, if we put in a 0 here and a 0 here, really that ends up being the y-coordinate the vast majority of the time. Then to get the x-intercepts, if you can factor, then you can take each of your factors and set it equal to 0. If it doesn't factor, or even if it does, actually, the quadratic formula will always give you the 2x intercepts, or if there are intercepts, it'll give them to you. But factoring is a little bit faster if you notice that it factors. And then, just like the other one, if that a number in front is positive, the parabola will open up. If the a number is negative, it will open down. So let's give it a try with this one. Negative x squared minus 2x plus 3 is our function. Just be careful about that negative in front. So first, find the vertex. Well, to find the vertex, we're going to get the x-coordinate first, and it's negative b over 2a, which here, the b is already negative, so it's really the opposite of that. It'll be 2 over 2 times, and my a in this case is negative 1. So we end up with an x-coordinate for our vertex of negative 1. Then once we have the x-coordinate, to get the y-coordinate of the vertex, we just plug it in. You got to be real careful because we're plugging in a negative number, especially in front. This first negative one is in parentheses, but then no matter what we get, we add a negative after. So get your calculator out and do some crunching. Here we should end up with a 4. So my vertex ends up being negative 1, 4. Oops, not 14. And part A is done. For part B, we need to find the x-intercepts. One way to get the x-intercepts is just use the quadratic formula. If we can factor, that can be a little bit faster. And I'm going to try that route just to show you something that'll help. If you have a negative in front of your first term, it's often helpful just to factor out a negative to make that factoring a little easier. And then that would change the sign of everything else. That doesn't always make the factoring work, but it'll certainly make it easier. And in this case, if we factor out a negative, and we're trying to figure out where this is 0, well, we can factor this one into x plus 3, x minus 1. And then that would FOIL out correctly, and then if we distribute the negative, we would get that function. So if we factor this way, then my two x-intercepts are x equals negative 3 and x equals 1. If you do the quadratic formula, you'll get the same answer, just a little bit more number crunching. Okay, A and B down, building our graph here. Next, we need to find the y-intercept. Y-intercept we got by just plugging in 0. Oops, not plus. Minus 2 times 0 plus 3 gives us 3. So my y-intercept is the point 0, comma 3. Next, we need the equation of the axis of symmetry. We didn't talk about this on the other screen, but they do ask for it sometime. The axis of symmetry is just that imaginary line that divides the parabola in half, and that always goes through the x-coordinate of the vertex. So we don't need to do any extra work, but you have to write it as an equation. The equation would be x equals negative 1, and it's just the x-coordinate of the vertex that we found over here. E, tell whether the graph has a maximum or a minimum and give the location. Well, the location is going to be the vertex, and in this case, since A is negative, this will have a maximum. And then just one thing to point out in terms of how the book asks the question. If it asks for the location, that would mean both coordinates. If they just ask for the maximum value, which is what they want a lot of times in word problems, that would just be the y-coordinate. If in doubt, if you just want to give both, that would be fine. All right, then next we need to graph the functions. So let me zoom out so I can see everything in my graph. So let me start with the vertex, negative 1, 4. Then I have x-intercepts at negative 3 and 1. And a y-intercept at 0, 3. And that ought to do it. And then I'll sketch it in. And there's my parabola. That covers part F, technically our graph. And then G is give the domain and range. Well, the domain, the x value is covered. We have arrows on the left and on the right. And yes, they visually look like they're pointing more down, but basically that means we go to the left and right forever. So our domain, our domain for this, and really the domain for any quadratic function, is just negative infinity to infinity. There aren't any x values we can't use. We don't have any square roots. We don't have any fractions. For the range, though, the quadratic always has, we're going to end up going to one end toward infinity or the other. In this case, since it opens down, our range would start with negative infinity. But then this one has a maximum. It goes all the way up and hits 4, and we actually use 4, so that end would get a bracket. And that covers our domain and range. All right, next we're going to work on a couple of different word problems. And right away in this first one, I noticed too late, that this equation is mistyped. The decimal's in the wrong spot. So for this problem, we're using this red graph, which is that equation, which is g of x equals negative 0.04. I had the decimal off in mine. X squared plus 2.1x plus 6.1. And really, there's nothing too tricky in the word problems other than just kind of wading through the information and figuring out what from what we were just talking about do we need to use to answer their questions. So we're dealing with a shot put. Basically, we're looking at the red graph right now, which is this one that reaches a little bit higher and then comes around. And then in the homework, you're doing the other one. So we're really trying to do this to help set you up for the homework. And so when the shot whose path is shown by the red graph is released at an angle of 65 degrees, its height can be modeled by our equation that I just wrote here. A wants to know what is the maximum height of the shot and how far from the point of release does this occur. Well, this is really just asking for, if we look at the graph, the highest point would be here. That's the vertex of the parabola. So we'll start by getting the x coordinate, which is negative b over 2a. In this case, that's going to be negative 2.1 over 2 times negative 0.04. Just be careful when you write and type that in. And so if we crunch those numbers out, we end up with 26.25. In this case, it would be feet. Now that's just the x coordinate. To get the y coordinate of the vertex, I need to plug that in. So I'm going to take negative 0.04 times 26.25 squared plus 2.1 times 26.25 plus 6.1, and I'm going to crunch that out, and I end up with 33.66. And so then my vertex and the maximum height, I should really answer their question. Max height is 33.66 feet. And how far does it happen? Happens 26.25 feet away. Okay, so that covers A. Let me make a little more room here. B, what is the shot's maximum horizontal distance, or the distance of the throw, it should be, not thrown. So we need the x-intercept here. This is not going to be one that factors nicely, so here's going to be a case where I'm going to want to do some quadratic formula. Decimals will get a little bit messy, but that's all right. So x equals opposite b plus or minus the square root of b squared minus 4 times negative 0.04 times 6.1 all over 2 times negative 0.04. So when you're crunching out a messier, longer quadratic formula like this, my advice would be to start with just get one number into the square root. So I would leave this front as negative 2. All of a sudden my stylus is not cooperating. Negative 2.1 plus or minus. I'm going to get one number under there. All over, now this is going to be negative 0.08. And when I crunch that out, I get 5.386. So then, now I can get just negative 2.1 plus or minus. I can do the square root of that to get 2.32. And then when we look at this, like at the graph, one of these answers is going to be negative, because this would technically hit somewhere over here. Well, that doesn't make sense. We don't want that one. So I just need to crunch both these out and take the positive one. And we can kind of use the graph to tell. Oops, I guess I drew that in wrong. we're dealing with the red graph. So ours is going to be somewhere here. It's still going to be negative. So that one won't make sense. We'll just take the positive answer. So now we just need to crunch out those two answers from there. So one time you do the negative version, one time you do the plus version. One of these gives me, when I do the minus version, I end up with 55.25. When I do the plus version, I end up with negative 2.75. Well, that's not the one I want. So the farthest it gets would be 55.25 feet for part B. And then C, from what height was the shot released? Well, that's really just the x-intercept. The y-intercept. I want to know when time was 0, where was the shot put let go? So you're just plugging in 0. Do that over here. So we would have negative 0.04 times 0 squared plus 2.1 times 0 plus 6.1. Well, that's going to go away, that's going to go away, so it must have been thrown from 6.1 feet. Oops, and there's my part C. All right, here's a word problem involving quadratic and a little bit of language with numbers. Among all possible pairs of numbers whose difference is 10, find a pair whose product is as small as possible. What is the minimum product? So I want to first find two numbers whose difference is 10, which means when I subtract them I get 10. So maybe I'll do, say, x minus y equals 10. And then I want to look at their product, which means if I take those same two numbers but multiply them together, and I want to make that as small as possible. Well, what's really going to happen here is we're going to end up with a quadratic that opens up, and we're going to look for the numbers that give me that minimum value, that vertex of that parabola. So to do this, what I'm going to do is right now I have two equations and two letters. I needed to get an equation that only has one letter left, so I'm going to do some substitution. So what we'll do is I'm going to solve this equation over here for y. And then we'll replace y in this other equation. So I'm going to do minus x minus x. I'm choosing to solve for y here because that's what we do more often. That'll make some of the other things we do seem more familiar. You could solve for x if you want, and that would be just fine too. Now I have negative y equals negative x plus 10. I'm going to divide by negative 1 to get my y be positive, and all that does is change the sign of everything over here. So now I know that y equals x minus 10, and I can replace y up here. So what I want the product to be as small as possible, which means I want x times y to be as small as possible. But I'm going to change that, and I'm going to substitute x minus 10 in. I want to make that as small as possible. I just made a legal swap so that I have only x's in my problem. And then if I multiplied this out, I would end up with x squared minus 10x, which is a parabola that opens up because here a is 1, it's positive. So I just need the coordinates of the vertex, and I'm all set. Well, the coordinates of the vertex, the x coordinate is negative b over 2a. We've seen that a couple times now. So here, that's going to be the opposite of negative 10. We have negative 10 if you want. It's going to become a positive 10 over 2 times 1. Not 2.1, sorry. Over 2 times 1, which would give me 5. So then to get my y coordinate, the other value I need to plug in, well actually, that's one of my numbers is the 5. To get the other number, I can just replace it in here. So if x is 5, my y has to be 5 minus 10, which is negative 5. Now, let's make sure we've answered the actual question. The actual question was, what is the minimum product? So they didn't want the two numbers. We need those, but the actual minimum product is what we get when we multiply those together. Ooh. 5 times -5 equals -25. All right, last problem is a word problem with some fencing. You have 300 feet of fencing to enclose a rectangular plot that borders a river. Find the length and width of the plot that will maximize the area. So what is the largest area that can be enclosed? Well, so we only have 300 feet of fencing to use. We're only going to fence 3 sides. The river side here I don't need to worry about. So whatever I end up picking for that side, the side across from it's going to be the same because we're making a rectangle. And then when I look at, if I have 300 total feet of fencing, whatever x is, I'm using that amount over here. So this third side, I would have 300 feet total to use minus 2 times whatever x is. And then, you can fill in numbers to try and see, different possibilities. But my goal is to figure out what x would give me the largest area when I do length times width. Well, length times width here is x times 300 minus 2x. So I have got to figure out what the x value is that would make this as large as possible. Well, let's take a closer look at this. My area is length times width, which I now know is x times 300 minus 2x. Well, if we multiply that out, we end up with 300x minus 2x squared. And if we write that the way we're used to seeing, my parabola, I have a parabola that's negative 2x squared plus 300x. So I've got a parabola that opens down, since that that coefficient of x squared is negative. I need to find the x that gives me the maximum y value, which is area. So I need to find the vertex. So my x coordinate is negative b, or the opposite of b, over 2a, which here would be negative 300 divided by negative 4, which is 75. So now I know that that side should be 75 feet, which means this side should be 75 feet. I need the other side here. So 300 minus 2 times 75 is 150. So it's a 75 by 150 rectangle, but I don't want the dimensions, I want the largest area. So my largest area is the 75 times 150, which would be 11,250 square feet, or feet squared. Now, the other way you could have gotten the area, I got the dimensions. You could also take this and just plug it in. That was technically the formula for area. If all they want is area, that's fine too. But sometimes they might ask you for the area, sometimes they might ask you for the dimensions, so it's good to be able to do both. And that sets you up for the homework.